Hello everyone, welcome back to my YouTube channel. Today we're going to discuss our next topic, which is empirical formula and molecular formula. So let's begin without any further delay. So we'll start with empirical formula. Now, what is an empirical formula? Okay, it is the formula showing the simplest simplest ratio between the elements. Now, if I can give you an example, we have CH3, CH4. I will later explain how this empirical formula works. First, we will discuss the definitions of both empirical formula and molecular formula. So, what is a molecular formula? You have to know the difference between both of them. Is the formula showing the actual ratios between the elements. Now, जिस तरह ये CH3 and ये CH4 है, तो अगर हम लिखें इसकी एग्जांपल C2H6 and C3H12, ठीक है? I will make it a different color. Okay, so if you take their ratio, which is 2:1, 2:3, 3:1, 3:4, it becomes CH3 and CH4. Now, this is the empirical formula. As you can see, I compared it with this. So this one is the molecular formula of this one, and this one is the empirical formula of this one. Understood? Now, our next thing that we will discuss is how to determine the empirical formula. Okay, so for example, a compound has 80% carbon, 20% hydrogen. Now, determine its empirical formula. Okay, so how do you determine the empirical formula? First, you will have to, number one, divide percentage by atomic mass. यहाँ पे कार्बन लिख देता हूँ, यहाँ पे हाइड्रोजन लिख देता हूँ. Okay, so 80% divided by atomic mass of carbon is 12 and hydrogen is 20, divided by atomic mass of hydrogen is 1. So our second step would be divide by the smallest. कैसे? 80 divided by 12 comes out to be 6.67 approximately, and 20 by 1 is 20. Now, divide by the smallest means that we will divide 6.67 by 6.67 and 20 by 6.67. Why? Because out of these two, 6.67 is the smallest. So we will divide both of them by 6.7 and we will get 1 and 3. And this is the ratio. So empirical formula is C, which is 1 H3 and hydrogen are 3. Okay, so how to determine the molecular formula. Now, empirical formula is CH3. Now, this is a question. Its actual molecular mass is 30. Now, how do we calculate the molecular mass? I will tell you later on. So, to calculate, I'll write it molecular mass as mR of the empirical formula. So, how many carbons are there in CH3? 1, and 1 carbon has an atomic mass of 12. How many hydrogen? We have 3. So, 12 plus 3 comes 15. So, we'll write 12 plus 3 equals 15. I will make a separate video explaining how to calculate the molecular mass. So, what we will do now is we will, number 1, divide actual molecular mass by mass of empirical formula. क्या करेंगे हम? 30, which is the actual molecular mass, divided by mass of empirical formula, which is 15. It comes out to be 2. Wait, I'll just write it like this. Okay, now we will multiply above ratios by 2 to get molecular formula. तो क्या करेंगे हम? CH3 को मल्टीप्लाई करेंगे 2 के साथ. It comes out to be C2H6 and this is the molecular formula. ठीक है? There's an formula for this, if you can memorize. It is, it's going to be molecular formula is equal to N into empirical formula. How do we use it? Molecular formula comes out to be N which is 2, this is N, and empirical formula which is CH3. So we will multiply 2 with CH3 to get C2H6. So for practice, we will do one question that is going to be what is the empirical formula of the oxide formed when 2.6 grams of chromium produces 3.8 gram of chromium oxide. Acha, so when you get mass or moles instead of percentage, first you will multiply or divide, sorry. You will write CRO. You will divide 2.6 by the molecular mass of or atomic mass of chromium, which is 52, and you will divide oxygen mass. Now, see, what is the empirical formula of the oxide formed when 2.6 gram of chromium produces 3.8 gram chromium oxide? Obviously, when chromium reacts with oxygen, it produces chromium oxide, right? So if it's 2.6 grams, this is 3.8 grams. So the if we subtract this, we will get 1.2 to get the mass of oxygen. Got it? So it will be 3.8. I'm gonna write this 3.8 minus 2.6. So we will get 1.2 and we will divide it by the atomic mass of oxygen, which is 16. We will get 0.05 and we will get 0.075. Now, again, you have to remember that, wait, divide by the smallest. Okay? So what is the smallest here? It is 0.05. We'll divide 0.05 by 0.05 and we will divide 0.075 also by 0.05. We will get 1 and this will get 1.5. So I'll write a note here. Multiply with such a number that you get the empirical formula in whole numbers. क्यों? क्योंकि ये फ्रैक्शन में नहीं होना चाहिए, तो हम इसको किस नंबर से मल्टीप्लाई करेंगे? We will multiply this whole thing with 2. So when we will multiply this whole thing with 2, we will get chromium to be 2 and oxygen to be 3. So what will be the answer? Cr2O3. Okay? So this is it for this video. If you found this video helpful in any way, so please like and subscribe and stay tuned for future uploads. Thank you.